newtons. Now, so let's take a look at this new term that we are going to learn in this lesson, gravitational field strength. So what exactly is it? In what way is it different from gravitational force? Well, before that, maybe I just give you an example of using the Earth, let's say. Okay, so let's say this is the Earth. Now, the Earth has a gravitational field strength is represented by the symbol G, italics G here. So the Earth has a gravitational field strength of 10 newtons per kilogram. So what exactly does it mean when I say that the Earth has a gravitational field strength of 10 newtons per kilogram? It means that if I have an object which is 1 kilogram, then the Earth will exert a force pulling it down, and this force of attraction, this force that's pulling, this gravitational force, is 10 newtons. So every 1 kilogram, the Earth will pull it down with a force of 10 newtons, and that's why it says 10 newtons per kilogram. So it is basically the amount of gravitational force that's acting on 1 kilogram of object. So now what happens if I have 2 kilograms? So if I know that the Earth's gravitational field strength is 10 newtons of force acting on every kilogram, if it's 2 kilogram, then what is this force that the Earth is pulling it down? The answer is 20 newtons. So as long as I know the gravitational field strength of this planet, I will know what is the force that this planet will be exerting on all the objects that is on the planet. So similarly, if you are, so let's say you are 50 kilograms, let's say your mass, you are 50 kilograms. Do you know then what is the, so if you jump up, we know that the Earth is definitely going to pull you down, right? So what is that force that the Earth is pulling you down? Suppose your mass is 50 kilograms. Well, the answer is every 1 kilogram, so based on this, every 1 kilogram, the Earth will exert a force of 10 newtons to pull it down. So if you are 50 kilograms, the Earth will therefore pull you down with 50 times 10, which is 500 newtons. So when you jump up, very quickly you will fall towards the ground because the Earth is pulling you down with a force of 500 newtons. And this 500 newtons has a special name. This gravitational force of 500 newtons is also known as your weight, because your weight basically is just another name for gravitational force that's acting on you. So let's revise a little bit. The gravitational field strength basically is the amount of gravitational force that's acting on 1 kilogram of mass. So as long as you know the mass of the object, you will be, and you know the gravitational field strength, you'll be able to work out the gravitational force. So the example over here, now this number you have to remember, okay? It is usually written in the question, but even if they did not, you should also be able to quote the figure, because Earth is the most common planet that we do questions. The question is based on. So the Earth's gravitational field strength is 10 newtons per kilogram. So always remember that on Earth, every 1 kilogram of an object will experience 10 newtons of gravitational force. Oops, sorry. It will experience 10 newtons of gravitational force. Is it the same for every planet? No, because the planet differ in sizes. The planets that are bigger than the Earth will have a larger gravitational field strength. The planets that are smaller than the Earth, for example, the Moon. Well, the moon's mass is roughly about 1/6 of the Earth, so the gravitational field strength is also smaller. So the gravitational field strength on the Moon is actually 1/6 the gravitational field strength on the Earth. And that's why when you go to the Moon, you experience a smaller gravitational force. So let's take a look. This is the formula that you have to be very familiar with. W equals to mg. Okay, this is a very important formula. If you're going to do upper set physics, you will see this again as well in a lot of chapters. You'll be using this. So W equals to mg. So what it means is that if I want to calculate the weight of a person, I will take the person's mass and I multiply by the gravitational field strength of the planet that this object is in. So say for example, this this boy has a mass of 60 kilogram and the boy is on Earth. So remember we said the gravitational field strength on Earth is 10 newtons per kilogram. So which means every 1 kilogram, the Earth will pull it down with 10 newtons of force. So if this boy is 60 kilogram, the Earth was going to pull it down with a force of 60 times 10, so that's 600. If the same boy is now on the Moon, the weight is different because the gravitational field strength on the Moon is 10/6 newtons per kilogram. So even the mass is the same. But by the way, whether you are on the Earth or whether you're on the Moon, it's important to know that the mass remains the same. Because when you go to the Moon, remember we said mass is the amount of substance? So the number of molecules, atoms that is inside your body, they don't suddenly disappear or multiply just because you go to a different place. So you are still the same person. Your mass will still remain the same. So it is regardless of the location that you are in. So when you are on the Moon, so you see, if your mass on Earth is 60, your mass on the Moon will also be 60. And then your weight will be, so every kilogram, this is the amount of force. Since you have 60 kilogram, you will then, sorry, I'm going to write it here. So this is the force acting on 1 kilogram. And because you have 60 kilograms, so you end up with 100 newtons. So you see, when you go to a different planet, mass, no change, weight will change. So if you go to a planet with a smaller gravitational field strength, then your weight will also be smaller. So remember our formula when we are going to start doing a lot of calculation questions. So always remember when you do calculation question, step 1 is always to write the formula. Step 2, to do the substitution. It's very important to present your work in a very neat and systematic manner. And then you give your final answer to 3 significant figure. Please, there should be no fraction. You are not allowed to give your answer in fraction. Bear this in mind. This could be slightly different from math, but in physics, your answer in fraction is not acceptable. So now let's take a look at this question here. There are 3 planets. So the first question, so remember to do this, you just need the formula W equals to mg. And W is in newtons, mass is in kg, your G is newtons per kg. Okay, do note the units. So if I have M, I have G, can I calculate W? Yes, I can. I will write W equals to mg. the mass is 50 kilograms, G is 10. So you see I write formula, I show substitution, and then I got my final answer here. So that is 500. So let's take a look at other questions now. The other two questions, you can pause the video to give it a try on your own, and then later you can then check the video for the correct answer. What about mass? Now, mass, in this case, the W is given, the mass is given, and you're asked to find G. Well, you don't have to remember so many formula. We will just write the same, since we know that these are the three terms. So I'm going to just write W equals to mg, 185 equals to 50 times G. So this is how we do substitution. I cannot stress enough how important it is for you to present your work in a systematic manner. Okay, it reduces all the careless mistake. So now I'm going to look for G. So G will be 185 divided by 50. So 185 divided by 50, I will get 3.7. So 3.7. Okay. If you look at the gravitational field strength of 3.7, you will realize that it is smaller than the Earth's gravitational field strength. So in a way, you will also know that the planet Mars is actually smaller mass than the planet Earth. So finally, on the moon, so same thing, I will write the formula. W is equals to 80. Hey, they didn't give me the mass. But if you look at the question, it says it's the same solid object. It is the same. Well, if it's the same object, which means that you will have the same mass. Remember, mass will not change regardless of your location. So you see the same object, right? So the mass is 50, 50. So this will be 50, right? So if you know the weight is 80, the mass is 50, then what is G? So G is 80 over 50, and 80 over 50, you will get 1.6 newtons per kilogram, right? So let's move on. Now for this part, you can pause the video and go get your pencil, eraser, and a ruler so that you can follow me as I do the question, okay? If I have an object and I want to show you the weight of this object. Now, when I'm using the word weight, I want you to know that it is the same as gravitational force, okay? So I use them interchangeably. So if I show you this object and I say, can you draw for me the weight? Well, how do you do it? So first of all, oops, sorry. So first of all, you need to locate where the middle of the object is. Well, assuming that this is a uniform object, so the middle of the object will be somewhere here, right? So this is known as the center of gravity, but I will not dwell too much in it. I think for Set 2 level, usually you just know that you draw from the middle of the object, or you draw from the point called the center of gravity, and they will tell you where the center of gravity is. So weight is always acting vertically downwards. So therefore, if I want to draw the weight, I will start from here, and I'll draw a vertical line, and I call this W, or weight. I can also call it gravitational force. So remember, always the middle, always vertically downwards. And please use a ruler. So what about if I put this object on a slope? Well, in this case, no difference, I will still want to know where the middle of this object is. Okay, I will still want to know where's the middle of this object. And the middle is here. So the rule doesn't change just because you put your object on a slope. I will still locate the middle and I will still draw it vertically downwards. This part will not change. So vertically downwards. So I'm going to put my ruler here and I'm going to draw vertically downwards. So here, completed the drawing of the weight. The next question. Why is there a difference in the person's weight on the moon and on the earth, even though the mass is the same? Well, if the question asks you to explain, you must always use a definition or a formula to support your answer. Sorry, I think this question you're supposed to explain why there is a difference. Okay, so I will answer as if there is the word explain there. So what can I use to support my answer? I will say because W equals mg. Weight is mass multiplied by gravitational field strength. Then I just need to say that the Earth and the Moon has different gravitational field strength. So therefore, the weight on the Earth and on the Moon is different. That's all. Okay, I'm able to say the weight is different on the Earth and Moon because weight is determined by this formula. And since the Earth and the Moon has a different G, therefore it will have a different W. The key thing is, please always in your answer to quote the formula. Let's go on, a few more slides to go. So what happened to your mass when you are brought to the moon? When you are brought to the moon, there will be no change in your mass. Remember, mass remains the same wherever you are. When you cut your hair, sorry, there's a typo error. But if you cut your hair, your mass will decrease because the amount of substance in your body is not the same anymore, right? Some part of the hair is gone. If you change your position, well, whether you're standing, sitting, the mass will still be the same. So again, there is no change in the mass. So two more calculation. So a quick one here. Some information about gravitational field strength on Earth. So remember, this gravitational field strength is the G that we are looking at in the formula. And the gravitational field strength on the moon is 1.7. So question 1, what is the if the mass is 8 kilogram, what is the weight on the Earth and on the moon? So I will say W. Now I want to calculate the weight on the Earth. So I write a little e here to show that it's on the Earth equals to mg. The mass is 8 kilograms. G is the G on the Earth. So you see I write a little e here because the weight depends on the location. So since it's the weight on the Earth, the G must be the G of the Earth times 10. It's 80 newtons. So this is how you present your answer. Similarly, on the moon, so the weight on the moon, so I'm going to write a small letter here, equals to mass. You notice I don't write down anything below mass because mass doesn't change. Then G on the moon. So what is the mass? The mass again is 8 times 1.7. So 8 times 1.7, I'll get 13.6. Do not forget your units. Question 2. What is the weight of the apple on the Earth and on the moon? Well, now you can pause the video and do this question on your own. Okay. So the answer is same thing, but I am very careful that apple mass is given in grams, so it's actually 0.2 kilograms. So I need to convert because this formula will only work if the mass is in kilograms. So times 10. So 2 newtons. And the weight on the moon is m, the gravitational field strength on the moon. So 0.2 times 1.7, 0.2 times 1.7, 0.34 newtons. Finally, so in this case, this is the final question where you have to combine everything that you have learned, and there are three forces: normal contact force, friction, and weight. So you're going to draw all the three forces here. So let me try to do it. So the first one, normal contact force. Refer back to your notes. Normal contact force always starts from the contact area and it moves away, it moves towards the object. So I'm going to move it a little off the center because later I don't want it to coincide with my weight. So this is the normal contact force. Okay, so this is my normal contact force. What about this one? Well, even if it's on a slope, it will still be from the contact surface towards the object. So this is, sorry, I have to draw it in. Okay, so this is my normal contact force. Let's go on to the other force, the friction. In this case, the object is not moving, so I will not be able to draw the friction because they didn't say whether the object is moving. So I have to assume that the object is not moving because no direction given. Then what about, oops, I'm sorry, I think this is, yeah. So what about this? Well, the box tends, if there's no friction, the box will have slide down. So which means that the reason why it's up there is because there is a frictional force that's acting this way. So this is friction. Remember, for frictional force, you must draw between the two surfaces and in the opposite direction from the motion or the tendency for motion. So it tends to want to slide down, so my friction will be upwards. Finally, last question, what about the weight? Well, the middle, I'm just going to roughly figure out. So that's the middle of the object. I'm going to draw vertically downwards. So this will be the weight. Over here is somewhere here. So this will be the weight. And there you are. We are done with the, oops, sorry. I don't know why this keep running away. Yeah. So we have come to the end of the slides. Thank you for, if you have been listening from the start till now, good job for your focus and all the best learning this chapter.